Objects. At the end of these videos, students will be able to define a set and an element of a set, use these symbols in sets, represent a set in extension form and in comprehension form, represent two or more sets in a Venn diagram, distinguish between finite and infinite sets, and define the cardinal of a finite set. Materials. Be ready. Before you start, please prepare the following materials: your textbook, pens, draft papers, and your copybook. Prerequisite. Before we start our chapter, you must recall some information about multiples and divisors, prime numbers. We say that P is a multiple of Q if P equal Q times K, where P, Q, and K are natural numbers. 15 is a multiple of 5 since 15 equal 5 times 3. And 20 is not a multiple of 8, since 20 equal 8 times 5 over 2, and 5 over 2 is not a natural number. 0 is a multiple for all numbers. We say that P is a divisor of Q if Q is a multiple of P, where P and Q are natural numbers and P different than 0. Example, 5 is a divisor of 15 since 15 is a multiple of 5. 8 is not a divisor of 20 since 20 is not a multiple of 8. 0 is not a divisor for all natural numbers since we have here P different than 0. We say that a natural number P greater than 1 is a prime number if P has exactly two divisors, 1 and itself. Example, 2, 3, 5, 7, 11, and 17 are prime numbers, since each has exactly two divisors, 1 and itself. Notation, 1 is not a prime number. Definition of a set. A set is a list or collection of well-defined distinct objects, such that each object is called an element of the set. Example 1. The students of your school determine a set. The natural integers determine a set denoted by n. The beautiful houses of your village do not determine a set, because maybe to me they are beautiful, and to you they are not beautiful, because the elements are not well defined. For more examples, take the students with green eyes determine a set. The teachers having aged more than 30 years determine a set. Notation 2. It is recommended to use capital letters to represent a set, and small letters to represent its elements. If A is an element of the set E, we write A belongs to E. If A is not an element of the set E, we write A does not belong to E. Determination of a set. A set is determined in two different ways, in extension and in comprehension. In extension, we say that a set is written in extension if all its elements are listed between two braces, and each two elements are separated by either a comma or a semicolon. Example 2, E the set of elements 1, 2, 3, 4, 5, and 6, and F, Sami, Ali, Ala, Fadi. E and F are two sets that are written in extension. Notice that each element of a set should appear only once. The elements can be listed in any order. In comprehension, we say that a set is written in comprehension if an exclusive common property of the element is stated. Example 3, E is the set of natural integers that are multiple of 7. E is a set that is written in comprehension. E is also written as E equal the set of x belongs to n, and x is a multiple of 7. Application 1. Consider the following four sets, A, B, C, and D. Write A and B in extension, write C and D in comprehension. Solutions. Venn diagram. Definition 2. The elements of a set E can be represented by points or crosses located inside a closed plane curve domain called Venn diagram or Euler's diagram. If an element does not belong to E, we represent it by a point or a cross outside the curve. Example 4. The diagram at right is the Venn diagram of a set E. Write E in extension. We have 4 points inside E and 2 points outside E. Then E is the set 1, A, 2, 0. These points that are inside E, and 4 and B, they are outside E. They are not in E. Subsets. Consider the set A of the students of your class and B the set of the students of your school. We notice that every element of A is an element of B. Then we say that A is a subset of B. Notation 3. If A is a subset of B or a part of B, then we write A is included in B. This symbol is called the symbol of inclusion. If A is not a subset of B, we write A is not included in B. Example 5. Consider the following sets A, B, and C. Write B and C in extension form, complete by included or not included. Solution. B is the set of natural integers between 1 and 7. Then B equal 2, 3, 4, 5, and 6. C is the set of prime numbers less than 8. Then C equal 2, 3, 5, and 7. To the part 2. Complete by included or not included. B and A. We have that B is a subset of A because all elements of B are in A. Then B is a subset of A, then B is included in A. B is not a subset of C because the element 4 here is not in C. Then B is not a subset of C. Therefore, B is not included in C. C is a subset of A because all elements of C are in A. Then C is a subset of A. Therefore, C included in A. Finite set and infinite set. Definition 3. A set E is said to be finite if it is empty or if it contains a finite number of elements. Otherwise, the set E is called infinite set. Example, the set of integers is an infinite set. The set of letters of the word mathematics is a finite set. The set of even digits is finite set. Definition 4. If E is a finite set, then the cardinal of E denoted by card E is equal to the number of elements of E. Notice that card E is a natural number. Application 2. Consider the following sets A, B, C, and T. Write B and C in extension. State whether each of these sets is finite or infinite. Find, if possible, the cardinal of each set, true or false, A included in D, B included in C, C included in A. Please pause the video and try to solve the application. Solution.